So, welcome to Marshable Math. And I had one of the original Marshables ask me for a little assistance with percents. And I said, well, I'd love to do that. So, get your pencil, paper, calculator. Thinking is work, and we do that work with the pencil. Pencil's the tool of the mind. Every time we're thinking, we should be writing. So, hopefully, lined paper. Let me switch my screen to you. There we go. Oh, I need the paper. Here's my question. Which is larger, 13/12 or 17/16? Now, the silly person would say, oh, 17's larger than 13. So, 17/16 is larger. And 16's larger than 12. So this has got to be the larger one. But remember from ratios that it's the comparison between the two numbers that's important, not the individual numbers. What we're saying is that the comparison between 13 and 12 is that the larger or smaller than the comparison between 17 and 16. So it's not about the absolute number. It's about the relationship, which is the difference between arithmetic, absolute quantity, and music, relative quantity. So now this is not how I want you to do it. So just go along for the ride a little bit. Um, the fourth grade way to do it would be to go, oh, we got to get a common denominator. Okay, what's the common number between 12 and 16? Um, 12 is 4 times 3. And so what if I did 4 times 3 times 2? Would that work? Would 24 work? No, it's going to be something. And 16 is 4 times 4. No, let's do this. Let's make it 12 times 3 times 4. Let's put all the factors together. 12, I'll do what I'm thinking out loud on paper. So this is 4 times 3. This is 4 times 4. We need something that's got all the same factors. So the one on the left is missing a second 4. The one on the right is missing a 3. So I'm going to multiply top and bottom here by 4. 4, it gives me 48. And this should give me 16 times 4, also 48. But if I multiply the top by 4, the bottom by 4, I'm going to multiply the top by 4. So 13 times 4, that's 52. And then 17 times 3, that's 51. Oh, look! Now that their denominators are equal, this one's larger than that one. So this is the larger one. Ta-da! And then at this point in the class, they usually something like, "Oh no, wait! I'm sorry, I gave you the wrong numbers." And the kids all say, "What?" And I said, "I'm sorry. I'm sorry. I gotta change the numbers. I gave you the wrong ones." And they said, "You have to do it again." And I said, "Well, what if we converted it instead of the denominator being 48 this time and maybe 36 next time, and I don't know, 63 some other time or whatever. What if we always make the denominator the same thing?" And that way you always, have to go through the exact same process rather than trying to dream up what's the common denominator. Just make the denominator the absolute same thing all the stinking time. And the kids say, "Yeah, that'd be better." Especially after if I make them go through a couple iterations of this, they get a little worn out. And I said, "Well, pick a number," and they're like, 5. Like, no, something bigger, something that you know, something that's easy to work with even. Oh, 10. Like, well, 10's actually a pretty good number because if you're gonna work stuff to 10 with decimals, you just move the decimal place. And I said, but let's make it bigger than that. And sooner or later, somebody says 100, and I said, oh, that's a good denominator. So instead of making 13/12 or 17/16 into 48s, let's make it into 100. And that, my dear friends, is a percent. Percent. Cent means 100. Per means divided by. So here's my question. I'm going to do a proportion now. Maybe you should watch my video on proportions. Proportions are two fractions or ratios that are equal to each other, and the cross products are also equal to each other. We solve them by setting the cross products equal. What was that first fraction there? 13 twelfths. 13 twelfths is the same relationship, that's the equal sign, as what out of 100? And this is called a percent because it's being divided by 100. And so if you set up all of your percent questions as proportions, like just like this, you're in. Doesn't matter which piece you're actually missing. The 100 always goes in the bottom right because that's the definition of percent. But now, like if you don't know, what percent is 13 twelfths? You're going to say, I don't know. And I'm going to say, that's great. Like, what's the symbol for I don't know? Usually it's X. Now, we've got 13 twelfths is equal to, it's very important, equal to X over 100. I don't know out of 100. The way that we solve this is we set the cross products equal. It's X times 12, which is going to be 12X. And then that's also going to be equal to 13 times 100. And I'm not even going to multiply them out because the next algebra step to get X all by itself on the left is going to divide both sides by 12. Because don't you agree that all of your X's should be all by themselves? So, X now is equal to, you can take your calculator, and it's going to be 13 times 100 divided by 12 times 100 divided by 12, and I get 108.3 repeating. So 108, if I go out 3 decimal places, 0.333. And so that's the number that would go right here that's out of 100. Notice it's a bit more than 100, just like 13 twelfths is a bit more than, 13 is a bit more than 12. So that's what, that would be 108.333%. That's what that little symbol means right there. I'm not sure where the etymology of that symbol comes from. Is it like meant to be a fraction bar or something like that? I don't know. I'll have to look that up. If you know, tell me in the comments. But that would be 108.333%. Now, how does that compare to the other one? Well, we have to do a proportion with the other one. Also make it out of 100. And then what was the other fraction? 17 sixteenths. What is 17 sixteenths? And then put the I don't know over here. Let's make it a new I don't know. Why? Because we don't want to get it confused with the original I don't know. That's going to be the new one. So stop the video and try it yourself. Come on, do it. Press pause. I'll check back in a second. Okay, it's been a second. So if I set this up, it's going to be 16 times y is equal to 17 times 100. And then I divide both sides by 16. Divide both sides by 16. This cancels, and I get y is equal to, now I do the math, 17 times 100 divided by 16. And of course, you knew the answer. This is 106.25%. And of course, the x is larger. Okay, so if you're working with percents, here's the basic template I want you to use. You're going to use a proportion. Fraction bar, equal sign. No, there's a rhyme for that. Line, equal sign. There we go. Line, equal sign. On the bottom of the right side or the left side, but I like to put it on the right side, is always going to be 100. That's the number that goes there. That's the whole. And then whatever the percent is, if you know it or you don't, that goes on top because that literally means the thing divided by 100. And then over here on the left-hand side, your whole is going to go down there. Whatever the whole of it is that you're talking about. And then on top, it's going to be your part. And what you're saying is that these two ratios are equal to each other in their relationship. Part over the whole is equal to percent over 100. You set this up, you're going to know 2 of the 3 parts. You're always going to know that this is 100. It's never anything different, but you're only going to know 2 out of the 3 of these remaining things, and you're going to be asked to find the missing part. Now, on the ones that we've just done previously, the missing part was the percent. The missing part was the percent. This would be a question that basically says, 13 is what percent of 12? And then you set it up that way. The of tells you what the whole of it is. The 13 is the part that you're equating with the percent. 13 is what percent of 12? Well, it's 108.333%. So I'm going to give you another question now. You interpret it properly into a proportion, and then pause the video and then solve it, and we'll check back. Here's a classic one. What is, let's see here. What is 87% of $592? Like, I don't know. Let's say that you go into a bank and it's a really good bank, and they're going to say, hey, we're going to pay you 87% interest. And you say, gee, I got $592. Like, what can I earn? Well, what can you earn? What is 87% of $592? Go. Press pause in the video. Okay, you pressed pause and now you're done. I would set it up as a proportion. Line, equal sign, 100 goes there. 87 is the percent now, but that's the part that I know. But that still goes over here. 87 goes on top. If 87 out of 100 is one relationship, what is that same thing over there? I don't know. Out of 592. See, you're saying it's the same relationship. The same relationship that 87 has with 100 has to be the same relationship as something I don't know yet is the 592. I solved this by setting the cross products equal. Actually, I'll show you the shortcut in a second. So x times 100. 100 times x is equal to 87 times 592. And now if I divide both sides by 100, I get this answer. And I'm going to do a little iPad trick. I'm just going to dump that. There we go. This is where you might remember shortcuts. A shortcut would be something that you say, oh, it's 0.87 multiplied by 592. That's a shortcut technique. Do you see that you get 87 over 100 as a decimal when you do that little part there in blue? But that only works when you're finding the part and you know the percent and you know the whole. If I switch it around and say, what is the percent? You can't use that. If I switch it around and say, what's the whole? Knowing the part and the percent, you can't use that shortcut. So if you set it up with a proportion and do the math properly, it always sorts itself out. So that's going to be 87 times 592, then divided by 100. That's going to equal the interest that the bank would pay you would be 515.04. And with interest or anything involving money, you really have to have two and only two decimals. This one, in case, actually accidentally winds up being two decimals. I guess I got to put the dollar sign too. And the dollar sign goes in front of the money. The cent sign goes on the back. Don't screw it up. I'm seeing a lot of people do that nowadays. It's very irritating. I'm trying to think of a joke real quick about percents off the top of my head. But it looks like time's up. What time is it, by the way? Oh, it's time to end the video. Bye-bye.